welcome and thank you everybody for taking the time out of your day to come and watch our presentations. It's greatly appreciated. First, I want to express my sincere gratitude to Brian and EJ for their invaluable instruction, never-ending patience, and guidance in the class. So my project, which I call the Perry3000 Smart Cooker, my grandson actually named it for me, is designed to assist individuals who struggle with basic meal preparation. It's cooking made easy. I'm a mother of 3 girls and 2 grandsons. Years ago, I obtained my bachelor's degree in computer engineering with a minor in physics. And I stopped working the past 10, 11 years to care for my ailing mother. And now I'm working on getting back into the workforce thanks to this program. Nurturing independence with individuals with special needs presents a unique challenge. Tasks like cooking that seem simple for you and I can present significant barriers. As a primary caregiver for my daughter, who is here on the right, who faces challenges from brain damage at birth, and also is autistic and has mild CP, cerebral palsy. My lifelong goal has been to empower her towards independence. At 35, she operates at a preteen level, and she really struggles with basic kitchen tasks. She was my inspiration for my capstone project. It's aimed to assist hers and others in food preparation. The smart cooker system transformed a conventional oven, or toaster oven in this case, as you can see, into an intelligent appliance, easing meal preparation for individuals like my daughter and others. It prompts users to scan NFC cards or tags, which you can see right here. And a user can also start the cooking process via a dashboard on Adafruit. The numbers are recipes that are hard-coded in. They can also put the system asleep, and they can turn the volume up and down. The system will automatically preheat the oven and monitor to the temperature and intervene if the temperature gets too hot. It'll cool it down. It'll determine when the food is done cooking and once it's cooled off enough for a safe food removal. All the while, it will prompt the user at each step where user input is required. It will also conserve energy by going into ultra low power mode and in between uses until it's reactivated by a push button. So some of the goals I had for the system was to obtain cooking instructions via an NFC card, to automatically turn the oven on, to determine when it has reached cooking temperature, to monitor the temperature, so if it gets too high, it'll turn off and wait until the temperature goes down, to verbally prompt the user to put the food into the oven once it's preheated, to determine when the food is done cooking, excuse me, and when the food has cooled enough to be removed from the oven, and then visually prompt the person to take the food out of the oven. There are reminders to have the user put the food in the oven or take the food out. After 3 reminders at 10-minute intervals, it will automatically shut off. And I also wanted to display the status of the system through NeoPixels and on a display. And I wanted to be able to enable remote initiation of the cooking process. and sent emails to the caregiver so that they can monitor the status of the oven if the user is cooking when they're not there. And this is the front of the case that I 3D designed. Being remote, you get one shot. If you make a mistake, that's kind of it, because Brian had to mail things to me. And unfortunately, I had my dimensions not quite right. So I was not able to put my circuitry into the box, which you'll see in the video. But I did want to show you what my design looked like. The system comprises of a particle photon 2 microcontroller, a relay optocoupler for turning the system on and off, the oven, Adafruit display, a mini MP3 player, 3 buttons. 2 are for volume control up and down, and 1 is for putting the system into sleep mode and reawakening the system. And a DF Robot NFC controller, and a hall sensor, which senses when the door has been opened. Some challenges were determining accurate cooking times, especially considering food cooling periods. I know that my daughter and a lot of her friends are afraid of the oven. They're afraid to get burned. So I thought that having the food cool off enough where it isn't quite so hot would make it more enticing for them to cook. And ensuring that the food is cooked properly. Establishing a method to confirm food placement inside the oven. Managing reminders of food removal without causing user frustration. I had a challenge implementing a watchdog that does a hard reset. Fortunately, we're not able to do that, only a soft reset. The reason for the hard reset is that if a device doesn't come online and we have to reset the system, the NFC card would not initialize properly on a soft reset. I wanted to wake up the system when scanning a recipe card. That NFC controller had an IRQ capability pin on there, but it did not work. So I had to go with the button. And getting the thermocouple to read properly and figure out what the offset temperature should be was challenging. I did have a faulty thermocoupler, and I had to fiddle with the code to make everything work properly, which it did end up working properly, but not as well as I would like. So I'm hoping to replace the thermocouple. Some improvements that I'd like to do in the future is replace the thermocouple. The capability for a user to create custom recipe cards, and a way for them to make their own recordings. Right now it's in my voice, which I thought would be good for my daughter, but somebody else would probably rather a different voice. I'd like to be able to, wake up the system remotely. Network wake up is not available on the P2. I'd like to be able to actually set a temperature on the oven. Right now, I cannot. I just have to turn it on and monitor it and shut it off when it's cool. And I'd like to be able to have the system wake up when a recipe is scanned. I'd like to be able to flash new code over the air. I think it'd be nice to have the system tell the user what food is cooking, and also display it on the screen and send that status to Adafruit. So if the caregiver isn't in the home, they can know what the person is cooking. And in order to do a hard reset, it's recommended by Particle, who makes the microcontroller, to add an N channel MOSFET that connects up to the EN pin so that you don't do any damage to the microprocessor, and you could do a hard reset that way. And this is just the notification chart, the different colors of the LEDs. can tell you the status of the system. I'm not going to read it all, because you can see that. And then these are the sound files. It's hard when I'm not pointing, I'm sorry. These are the sound files with descriptions, which you will hear in the video. And this was my 3D model. And this is my flow chart. It's very hard to see. These were the text messages that I received through integration with Adafruit from Zapier that would alert the caregiver to each status. And my schematic and Fritz diagram. And then in conclusion, the Smart Cooker project aims to improve quality of life for individuals and their caregivers by addressing challenges in everyday tasks like cooking. Now I will share my video. Give me a second. Oops. It seemed to want to open up. Okay, here we go. I start off the video just trying to show you each step. And then towards the end, I'm teaching my daughter how to use the Smart Cooker.
Wait to scan the recipe until the lights turn green. You can now scan the recipe card. The recipe wasn't scanned. Please scan the recipe again. The recipe is scanned. Wait for the oven to heat up. Put on your oven mitts and put the food in the oven. The food is cooking. The food is cooling. Wait to take it out of the oven. Put on your oven mitts and take the food out of the oven. The recipe is scanned. Wait for the oven to heat up.
Hi, I'm Brittany, and I want to be able to help my mom and cook independently.
So what are you going to pick out for your supper? Do you want to look in the freezer?
This freezer?
Yes, that freezer.
Cheese.
Can you show me what you picked out? What is it?
Macaroni and cheese.
That's what you want for supper?
Yes.
Okay, you're gonna cook it. Okay, now can you find the right recipe card? What are you gonna eat? Which one is that?
Macaroni and cheese.
Okay, all right. Grab the recipe card. You can just put it right there for now, okay? Now, you have to push the on button, and that's this one right here. Okay? Good job. Now let's hear what it says.
Wait to scan the recipe until the lights turn green. You can now scan the recipe card.
Okay, get your recipe card,
Scan it.
and you put it on that. Okay, take it off.
Recipe is scanned. Wait for the oven to heat up.
Well, let's see if the oven started. And see, the lights are yellow. That means it's heating up. And it's on.
Put on your oven mitts and put food in the oven.
Did it go off?
Now you have to put the food in the oven. Use your oven mitt. Good job.
Yes, I know.
I have to keep reminding you. All right, good job. Now, make sure it's cooking. Yep, the LED's red.
Put on your oven mitts and take the food out of the oven.
Okay.
Hey, buddy. Take the food out of the oven without stepping on him. I don't want to step on the little guy.
You can put it right on the plate. There you go.
Let it cool down.
You want it to cool down some more?
Yeah.
Look at me.
It's hot.
Good job. Is it good?
Yeah.
Did you do a good job? All right.